Okay, the next problem is such. We have two members. One's a half circle that goes from A over to B, and then the next is a angle link that goes from B. I need to turn off the ink to shape. It goes from B, angles around at C, and then is pinned here at D to this wheel that contacts the surface up here. We have a load on this wheel of 20 pounds. And that's it. And these are the dimensions. So this is a circle, so it is 3 high. And there we go. So let's draw some free body diagrams. Okay, so free body diagram number 1 is, let's do the whole structure. So this is the whole structure, which means I have a CX, I have an AX, or an AY, and an AX, and then I have 20 pounds. I guess I usually draw this with a green line. Let's go ahead and do that. 20-pound load. Okay, that's the whole structure. For free body diagram number 2, let's just draw this wheel here that is at D. So this is D, and I'm going to draw dx and dy as the reactions. And then on top of that, I have a normal force here where the wheel touches the other surface. Let's get rid of this line. Go from the bottom edge here. Force normal. I guess we'll draw it like that. And then I have one more reaction because this has 20 pounds. I have 20 pounds in addition to this that is centered at D. So we'll draw something like that, I guess. Okay, let's go. Let's continue on. Free body diagram number 3 is, I'll just do this half circle thingy. So it has an reaction at A, the support, an AX, and then over here, it's pinned to this link. So let's toss in 2 potential reactions there, BX, BY and BX, and then this contacts the wheel here, so it's going to be opposite to the way I drew that Fn, but we can have the same force, Fn. Okay, finally, free body diagram number 4 will be this angle piece here. By itself. So I have the CX reaction here. Now, I have BX pointing to the left over there, so I have to make it point to the right here. So they're equal and opposite, and I have to make BY point down. As we connect this, this connects to D here. So it's not connected to Fn, but it connects to D. So I need we'll get rid of this and put it in again. I need a dx in this direction. And I need a dy pointing down in this direction. And that's it on this guy. So this is free body diagram number 3. So let's do some analysis. So using free body diagram number 2, I'll sum forces in the x equals 0, And we see that all we have is a dx there. Therefore, dx equals 0. Let's go ahead and turn this on so we can get some nice boxes. Okay, so again, when you do these as homework, you don't want to start rotating back up your document. You always want to move down. Move down and do your calculations in series. So, free body diagram 1. I don't think I'm going to be able to draw D's without them turning into circles, but keep that on. So, I'm going to sum forces in the y direction equal to 0. So what I'm using is this whole diagram here. And as we can see, I can figure out what AY is because it's the only y force opposing the 20. So this equals AY minus 20 pounds. Therefore, AY equals 20 pounds. Okay. So now let's look. Okay, I know what AY is. I think I can use free body diagram number 3 here, and I can sum moments to figure out what that F normal is. So free body diagram number 3 now is sum moments about B equals 0. So I'm going to choose B over here because it eliminates those two unknowns over there. And I know what AY is. And AX goes through that point. So I'm going to get this minus AY times 6 minus F3. F times 3. Sorry. So therefore, force F is going to equal minus 40 pounds. Now I'll choose free body diagram number 2 so I can figure out what dy is. This is one of the things we need to solve for. And I get minus 20 pounds. Since I figured out what F is from above, I'll use free body diagram number 4 next. And from this one, I have 2 3s here. This is a 4. And we see that BY now equals 20 pounds. So now we have dx, dy, so we found d, and we have by. The only thing we need is bx. I'm going to leave that to you to solve for using one of these free body diagrams. So the next problem is a little more challenging. Let's draw some free body diagrams. First, let me draw the full structure. So I'm going to have an AY here. Turn the shape to ink off. And AX here. This is a 2-force member. So I'm going to have a force of, we're going to call this force BD at this link, or at this pin. And then I have force P here, and I have force F here. And we can calculate what F is, since we know that we've got 6 kilonewtons per meter, or 6,000 newtons per meter, times 0.025 meters. This equals 150 newtons. If this is our spring constant. No, wait, got that backwards. Spring constant K here, and our delta, or distance. So our second free body diagram, it goes from E to C. This is D here. We have a load P on this. We have our force here that is drawn, so this is in tension. So this has to be force BD, has to be drawn in this direction based on how I drew the line over here. And this is our reaction over here at C, CY, and CX are pins. I can draw those anyways because that's the first time I drew it. Okay, next member is ACF. Okay, we have this force here. Have to draw it the same. It's 150 newtons. Here's C. This connects up with this C. So I have to oppose CY here, and I have to oppose CX here. And then A, I have drawn like this, AY and AX. We can draw DB, but I don't think I'm going to use it in analysis, and it's just a two-force member. So I'm going to move on to the analysis. Okay, I'm looking at this picture, and I see that I need to find what P is. So if I can do something with FBD here and P, I could sum moments about C if and get a relationship here. It doesn't look like any relationships in any one of these free body diagrams is going to spill out an exact answer for me. So I'm going to have to probably do a system of equations. So, okay, let's do this. We know what F is in free body diagram 1. Let's take moments about A in free body diagram number 1. Okay, so I begin with minus P times 550, the easy part, minus 150 times 1,000. That's this times a distance of 800 plus 200 is 1,000. And then I have a component of FBD times this distance, which isn't given. I'll have to calculate that using a triangle. So that's FBA times cosine 30 for the component. And then I have this distance plus this distance here that I have to calculate, which I can do. And that calculated distance is 400 tangent of 30. So I add that to 200 for the moment arm there. So I'll solve for P here, and then I'll do my calculations here, get me a function. P is a function of FBA. And we'll call that equation number 1. Okay, so I have a function with a P and FBA. So let's look at our picture again. And as I was guessing, if I take free body diagram 2, I can sum moments about C. And that gives me only the two variables F, B, D, and P, another equation, independent equation of F, B, D, and P. So if I sum moments about C, I get minus P times a moment arm of 350 times the force of BD sine 30, which is the component, times a moment arm of 200. Solving that, these should all be BDs. So I get force BD equals 3.5 P. Call this 2. Solve 2 and 1 simultaneously. So if I go back and correct this, dividing by 550, and I do the whole calculation as much as possible, I end up with P equals 198.35 and force of BD equals 694.23.